In this video, we want to solve this inequality with log base 2. So the first thing we're going to do is use one of the properties where if you have addition of logs with the same base, you multiply whatever's inside the parentheses. So here we're going to multiply the x plus 2 with x plus 4 and have that under one log. Now we're going to rewrite 3 as log base 2 of 8. And the idea here is that, well, these have the same base, so because log is an increasing function, we can cancel out the logs and just look at x plus 2 times x plus 4 is less than 8. So now the goal is to solve for x. So I'm going to FOIL this out and get x squared plus 6x plus 8. That's going to be less than 8, so subtract both sides by 8. To get x squared plus 6x is less than 0, factoring out an x. And now at this point, we set each factor equal to 0. So x is 0, and so is x plus 6 equal to 0. And so we get x is negative 6. So we're going to draw a number line. And now we're going to see, okay, let's pick a number left of negative 6. Let's say it's negative 10. Plug it in here, you get a negative number. Or sorry, you get a positive number because two negatives multiply give you a positive number. And let's say we plug in a number between negative 6 and 0, say negative 1. You have negative times a positive is negative. And let's say plug in a number greater than 0, say 1, you get a positive number. Now, you didn't have to plug in the numbers because you know that x squared plus 6x is quadratic and opens up like this. So clearly it's going to be positive, negative, positive. But we're interested in when is it negative. Well, clearly it's negative in this region here. So from x being between negative 6 and 0. But now the problem is that the domain for logs are restricted. So for example, if I have log base 2 of x, the domain is all x such that x is greater than 0. So you want whatever's inside to be greater than 0. So for x plus 2, you want x plus 2 to be greater than 0. So in other words, x has to be greater than negative 2. And then same thing with x plus 4. You want x plus 4 to be greater than 0. So that means x is greater than negative 4. Now, we can't just have, let's say, negative 3 works for log base 2 of x plus 4, but doesn't work for log base 2 of x plus 2. So you want to look at where do these both overlap. So if you draw a number line from negative 4, if x is greater than negative 4 and x is greater than negative 2, they both overlap when x is greater than negative 2. So if we go back here, we said the solution was x being between negative 6 and 0, but clearly negative 6 to negative 2, the domain is not part of the domain. The domain has to be greater than negative 2, so we're going to change this to say that x has to be between negative 2 and 0. And so this is our final answer.